Hello, everybody, and welcome to today's session. We're very lucky. We're joined by the School of Physics, Engineering and Computer Science for a very special computer science webinar today. And it'll be looking at your project journey. So this will be looking at the BSc and MSc computer science projects. Now, just in case you're new to Zoom, you should be able to see a chat icon where you can start speaking to fellow participants, maybe future classmates as well. And you should also be able to see a Q&A icon as well, where you can start adding in questions and we can get those answered at the very end of the session. But just to introduce myself, I'm Jess and I work in the international office. And we're joined by Mike today, who I'll be passing over to begin the session.
Hi everybody, my name is Mike Watkins. I'm the program lead for the MSc Advanced Computer Science and then the module lead for the MSc Computer Science project and the BSc Computer Science project. And one of the things I think that's really important for students to know and then try to benefit from is the purpose of the project journey. So if you are doing an MSc, this will apply, and also if you're doing a BSc, this will really apply. And we'll talk a little bit about the differences as we progress. So if you have any questions as we go through, please feel free to drop it into the chat or just raise your hand, and Jess will just hold me for a second and we can have that conversation. Optionally, I think there's a Q&A session at the end, so you could also make notes and ask it at that point. Next slide, please. So I think the value in this experience is to understand what makes a successful project. So I thought it'd be really useful for us to talk about what it means in terms of, having an idea, what an idea looks like, thinking about some example projects to get your sort of creative juices going. Talk about things like the research aspect. So if you're doing an MSc project, it has to be a research-driven project. If you're doing a BSc project, it can be a sort of a create an artifact type project. So we'll talk a little bit more about those. Talk about the implementation. How do we go around sort of implementing it, building it? And then really importantly, how do we evaluate what we've done? What does it mean to evaluate? Some of the common pitfalls, and really about how this stuff will align beautifully, if you want it to, with your career goals or your further study goals or your research goals. And I think that's the most important thing, is that when students arrive to do a degree, the biggest, most challenging module that they have to do will be the project. And the project is a phenomenal opportunity to do something that you are passionate about, or that's something that you're interested from a professional point of view or interested from a personal point of view. This is the single most challenging and largest piece of work that you'll do. So getting this right is a requirement for you to achieve your degree, because if you can't be successful on the project, unfortunately, that will have an impact on whether you can complete this sort of degree. So don't worry about the project. It is a big piece of work, but it is the only opportunity for you to do something purely that you're interested in. It's not, you define the requirements. So it is a really awesome opportunity, and some that you can do that may end up you spinning up an organization. So we have some students that have recently completed their MSc and they've actually started businesses off the back of them. So it is a phenomenal opportunity, but it is a big piece of work. So I think if we can kind of talk through that process and help you understand how to use it, maximize it, I think that would be a really good use of our time. If you have any questions, obviously we can talk about those at the end. Next slide, please. So why does the project matter? The thing is, as we've already talked about, the project is the single biggest piece of work that you will do. So if you're doing an MSc qualification, you're expected to invest about 600 hours in your project, which is effectively a full-time job, 8 hours a day for sort of 3 months or so. Or if you were to not take any breaks, not take any sort of sleep, it would take 24 hours a day. You probably take about sort of 20-25 days to complete it. So the key thing is it's important because it is the sort of the cornerstone. It is the sort of the building block of your qualification. But not only that, it's the thing that will align best to industry. It's the thing that will align best to your sort of, if you're interested in doing further research or further studies. But more so, it's your opportunity for you to do something that you are really, really interested in. It's an opportunity for you to do some research. It's an opportunity to explore technology. It's an opportunity for you to look at the challenge that exists and come up with a solution, try to build that solution. And then the great thing about it from an academic point of view is that if your project fails, that doesn't mean to say that you failed the project module. Unlike industry, whereas if we can't deliver something that works and is right, it's a failure. In academic terms, the failure is that you haven't learned something. So although it's a huge piece of work and a really, self sort of directed piece of work, and you'll get a supervisor to help sort of navigate the sort of the challenges, it's an opportunity for you to invest your time in something that you're really interested in, about whether that's sort of technology or research. And one of the key things is it's something that when you go for a job is that you can kind of showcase that you're capable of doing this, or if you're going for a promotion, it's something that you can showcase. So, it is the biggest challenge that you're going to have with regard to either the BSc standard or the MSc standard, but it is the most unique opportunity to do something that you are truly focused on and get a qualification and be able to sort of maybe spin up a business from it. So it's a really important element. Next slide, please. So a project is a substantial piece of work. By definition, a project is something that we don't know that we can do. If it's something that we know that we can do or we've done it before, then it's a task. So the key thing to think about is a computer science project is something that we don't know that we can achieve. It's something that we don't know what the requirements are. So the whole point of it being a project is that we're going to follow a set of steps to try to reduce failure, to try to identify what we need to do, and then to try to manage the time and resources needed to do it. And then at the end of it, try to evaluate it to see whether it actually meets those requirements that we identified. So it's an evidence-based investigation. That's a really good way to describe it. There's a technical aspect to it, there's a research aspect to it, and there's an organizational aspect to it. So when we talk about a computer science project, it is not something. I mean, effectively, what I'm trying to say is really, if you start the project and you go, well, I don't know whether I can do it. I don't know what problems I'm going to have. I don't know how to do it. Those are all really excellent starting points. You might think that it's not ideal, but that's the start of a project. The whole point of a project is try to identify what you need to do, then plan how you're going to do it, then look at the resources that you need to be able to do it, what challenges and what risks you might have, and then try to address those risks. So that's the point of a project. A project is not a task. It's not something that you know how to do. It's not something that you know that you can do. A project is something that you're going to try to do, and you're going to do it in a way that actually tries to ensure more success rather than failure. And a lot of times, that the outcome of a project may be that you didn't achieve what you wanted to achieve. But that's not a bad thing in academic terms. In industry, that's not a good thing. But in academic terms, being able to achieve what you say you will achieve is not a bad thing if you can't achieve that. So don't panic about whether you can do it or not. The challenge has to be sort of trying to be sort of scoped so that it's enough of a challenge. Because really what we want to see is well, what did you do? How did you know how to do that? How did you know that was the right thing to do? So that's really what we're looking for in terms of evidence. You can't just say that everything went well. Well, you can, but that's not going to get you a good mark. Can you explain what went well, but also what didn't go so well? Dealing with problems is a huge skill set, especially in industry. So when you come across a problem, it can be frustrating, I know that, but more importantly, it's how did you deal with that challenge? Because if you're money motivated, then dealing with problems and resolving problems is going to be an important skill set. If you're challenge motivated, then dealing with unknowns and maximizing success is going to be something that is going to be really valuable in terms of moving forward, in terms of working skill sets. So this is your opportunity. The project is the single best opportunity for you to do something that you're focused on and that you are interested in, but also don't panic about whether you can or can't do it. That's the point of the project. The project is an attempt to minimize failure and maximize success. Next slide, please. So projects are not just about coding. The key thing is that a lot of students think that they have to be good programmers. Part of it is that we will expect some kind of technical aspect. In terms of computer science, the ability to program is a core requirement. But it's not just about coding. It's about research. And research is what questions would be helpful for you to know the answers to. So you might have technical questions, you might have academic questions, you might have psychological questions in terms of how what would cause somebody to come back and use this system. So if you've ever played computer games and you understand that there's sort of like an engagement sort of metric, a sort of a game theory where people are kind of rewarded for certain things. So you might want to think about, well, what do I need to know, or what would be useful for me to know in order to maximize the success of this project? So there is a coding element involved in it, but really what we're interested in is the research. What questions and what topics did you research? Why did you research them, and how does that help you deliver a better product or run your project better? And then analysis in terms of, if you've found some results or you've looked at the problem, how do you now analyze and break that problem down? So we're looking at things sort of like decomposition. So let's take a simple example, is that the challenge is that we want to build a house. So the first thing that we could do is understand some of the research. So we might want to look at, well, what are building materials? How do we go about, building a house? So that's part of your research topic. And then an analysis is, well, what do we want the house to do? How big does the house need to be? Why does the house need to be that big? So really, it's about critical thinking. And critical thinking is not just making statements, but it's about answering interesting questions. And these steps are really about helping students or people, engaging in projects to solve the problem. And the problem isn't a negative thing. The problem is just some kind of challenge that we're dealing with. So research, what do we need to know? And how do we know that actually what we understand is correct? Analysis is, let's break the challenges down. Let's decompose the challenges into sort of the various sort of smaller segments. Design really is, well, what is the architecture of this? What is the look of it? How do we want people to engage with this? How should people engage with it? The implementation is, okay, so we understand what we're going to do. We understand generally what it's going to look like. And we understand what the requirements are, the things that will make it work. So now the implementation is, well, what do we need to do to bring this into existence? And there's certain things that we can talk about. We can talk about different methodologies for implementing. So, for example, we can try to build small little example sort of ways to solve the problem, and then once we understand that on a small scale, we can kind of reiterate and make it bigger and make it, take what we learn from that small scale and then make it bigger. Optionally, we could adopt what they call like the walking skeleton approach, which is, if we're going to build a car, let's not worry about building a car. Let's worry about building something that can represent the values of a car. So maybe instead of building a car to begin with, we might build a skateboard. And you go, well, a skateboard isn't a car, but it's a form of transportation. It's got wheels. It's got something that you can sort of stand on or get in. But effectively, the problems of building a skateboard is significantly less than building a car. So let's build a skateboard as a complete solution to allow you to move from A to B. And then once we've got a skateboard, we can make it more complicated. We can add levels of sophistication. So maybe we can make a scooter, and a skateboard is basically, or a scooter is a skateboard with handlebars. So again, we're not trying to solve the car problem. We're trying to solve a transportation problem. So now we can go, well, we've got a scooter, so let's make an electric scooter or an engine-based scooter. So now then from there we can make maybe a motorbike. And from a motorbike we can make a quad, and then from a quad we can make a car. So what we're trying to do, or what you're doing, is that you don't necessarily know how to build a car, but you can represent the challenges with something much, much simpler. And then once you understand how to do that, then you can move up to the next level of sophistication, or the next level of sort of design. And once we've got that process, and again, even if you don't get to the final version, you're showing that you're implementing sort of, and you're structuring, you're solving a problem step by step, and that actually will help you get a really great mark. And in industry, that's how you solve problems. You might not be able to solve the full problem to begin with because you don't have the experience, but you can solve the problem, get up to a point, and then sort of understand the problem better, and then move on to that point. So the key thing, the skills that you're going to experience and use and build, are really fundamental to problem solving, are really fundamental to industry or further research. So you understand what your challenge was, you've done some research, you've thought about the design, you've thought about the challenges, you've done some implementation, you've built up some things. So now the next thing to do is, well, how do I know that actually what I've got is fit for purpose? How do I know that it's the right thing? So that's really where testing comes in. So testing is, well, how did you test, to make sure that what you did met the requirements? And maybe it doesn't meet the requirements. That's fine. If it doesn't meet the requirement, how far away is it from meeting that requirement? So the testing is an opportunity for you to demonstrate your professionalism and your thoroughness and your diligence with regard to what you've done. So one of the worst things I think students tend to do is they go, well, it's great, there was no problems and it couldn't be better. The problem with that is it doesn't have sincerity. Everything that, nothing is perfect. Things could always be better. So the key thing here is not to worry about saying that it didn't go as well as you wanted to. If it didn't go as well as you want to, it gives you a story to talk about. It says, well, I wanted to do this, it didn't do that. And then you can talk about, well, why? And when you're engaging with your sort of supervisor, or you're presenting your project at the end of the journey, having been able to discuss the challenges and your decisions and your understanding and how you tested it is really the way to get a really good score. So a lot of students panic and they think that if they do anything wrong, it's a problem. The key part is doing things wrong is actually a really good way of doing the project, because we learn more from what doesn't work. So if you say that everything is fine, the question then is, well, did you test it? What are the things that could be better? So don't panic about if things don't work. That's the key thing, is do something that you're interested in, and that will help you drive through the sort of the investment that you need to make in order to get the mark that you want. So testing is your opportunity to sort of shake your project and see what's loose. Talk about what's loose. You can talk about why it's loose with hindsight, or you can talk about why it's loose with decisions that you made. And as long as you can explain what you've done and why you've done it, then actually there's academic value there. If you just say, well, I did it, that there's minimal value there. So again, you've built something and now test it. And then the final part really is an evaluation. How did things go? So when we talk about a project, we're not just talking about an artifact or something that you're building. What we're talking about is the method and the approach that you took to identifying the problem, to researching the problem, to the time taken to design a solution, the time taken to build a solution, the decisions around what technology you might have used, how you tested it, what your testing found, and how well did you use the time that you had. So one of the key things is you might have sort of 10 weeks to build a project, which is not a lot of time. It feels like a lot of time. But actually, you've got a lot of work to do in there. And it's work that you define. So being able to evaluate how all of those things went demonstrates that when you're given a task, is that you can hold yourself to account. And you can hold yourself to account not in a sort of a defensive way, but in a critical way that says, well, this could have been done better, that could have been done better. And the key thing is that gives you an opportunity next time to do better. And the key thing between being professional and not being professional is experience and capability. And you gain experience and capability by taking on challenges that are by definition challenging. And then you look at them and go, well, how could I have done better? So that whole process is the learning experience. So as long as you can talk about that with sincerity and you can demonstrate your thinking, is that you will get an excellent mark. But not just an excellent mark, it will give you significant opportunities that the next project that you get involved with, you'll be able to do it better, you'll understand more. And then the final part is just the reflection. What went well for you? What didn't go well for you? What personal skills did you develop? What personal skills did you have? What were the unexpected challenges? So effectively, the project is the story of you trying to solve a problem. The coding part is important. Coding is a very good skill. And effectively, coding is a problem-solving skill. You're using structured language to create an algorithm, sort of a set of steps that solve a problem. And if you write a robust set of steps, then it means that you're going to get a robust solution. But again, coding is it doesn't really matter what language you use, or it doesn't really matter sort of, what sort of technology stack you use. What you're using coding for is to implement your solution. And there's other coding things. You don't have to, you don't, I mean, coding is a good skill, but there are no code platforms as well that allow you to construct logic, without actually writing what would be conceived as sort of, Python code or C# code. So there's a lot of different ways that you can solve the problem. So coding is not the main challenge. The main challenge is, what problem are you trying to solve? And then really, how are you solving that? So again, it's really that journey. Next slide, please. So one of the first things that students struggle with is they say, well, how do I get a good idea? So a good idea comes from something that you're personally interested in. So are you interested in exploring a technology? Are you experienced in a certain technology? Are you interested in a certain aspect of industry? What problems exist within that aspect of industry? What challenges exist? Are you interested in looking at some research and going, I'm really curious as to whether I think that I could do something better than that, or can I approach that research in a different way? Or is it something work related? Is it something that actually would help you in your current role? So to give you an example, many years ago, I was involved in sort of support services and help desk management. And one of the things that I did is that I designed a system that allowed me to do my job better, more quickly. And as part of that, I got promotions. And really, that was a project. In terms of industry challenges, if you have a hobby, or if you are aware of certain issues within industry, or certain challenges. So, I mean, we're in the education industry. There are certain challenges, in the sort of the retail industry, there'll be certain challenges. If you have personal areas of interest, so I had a student that was interested in monitoring traffic, air traffic, and they bought a small little gizmo that I think was about sort of 40 or 50 pounds, and it basically picked up the frequencies that aeroplanes transmit, all aeroplanes transmit, and then they were able to apply that to a sort of a Google Map system, and they could monitor air traffic control, like a little air traffic control tower, pick up all the details. They were then able to kind of connect that sort of the serial of the plane to a flight information. They were able to identify what plane it was, where it came from, where it was going to, the sort of type of plane, and they could monitor all that in real time. And that was something that they were personally interested in. So again, one of the key things for you to think about your project is, you will have to do a project. Whether if you're doing a degree, a project is sort of the capstone piece of work, and it basically is an opportunity to bring all of the aspects of what you've been studying and your personal experience and your personal areas together. And it's the only place that you can do that. And you will get a really good qualification for doing something that you're hopefully really, really interested in doing it. And, you're going to work with your supervisor and the module team, and you'll be able to discuss ideas and things like that with colleagues and students. But the key thing is that this is something that should be really exciting for you to do, and something that is really aligns with the area that you're interested in. It could be frustration, it could be the fact that is that you've got sort of 3 kids, or you're maybe you need to entertain 50 kids, or you need to kind of show them some information or check their learning. So it's really a question of think of an idea, or a problem, or a challenge that you're aware of, that you personally have experience with, or that you understand there is a problem with, and that can form the sort of the nucleus of your project. And like I said, this is the only module that you have autonomy to do that. You are totally in charge of every aspect of your project. Your supervisor is not there to give you a project. Your supervisor is not there to give you permissions to do your project. Your supervisor is there to be your critical friend. They're there to help, present you with challenges, or ask you questions on what you're saying, to help you be prepared for when you present your demonstration, so that you get the mark that actually truly reflects your capability. Next slide, please. So in terms of computer science is this really big umbrella term, and we've got things like artificial intelligence, cloud computing, software engineering, data science, and then sort of human-computer interaction and accessibility. So your project opportunity can pick, 1 or 2 of those areas, and that could add value, or it could augment the sort of the project that you're doing. I mean, you could use AI in terms of as part of the architecture of your problem. So it tries to solve a problem using AI or machine learning, or you could provide an AI system or a machine learning system in order to solve a problem. So where you use these elements can help you define the requirements or scope of your area. But the key thing I would say to you is that this is a large project. So if you're doing a BSc, an undergraduate, then you're expected to spend 300 hours. And that's not 300 hours of coding. That's 300 hours of thinking, 300 hours of research, 300 hours of design, 300 hours of testing, 300 hours of writing, in that time. So how you break that time up really is about how are you managing your time. And you might be really good at managing your time, or you might be really bad at managing your time. And if you're really bad at managing your time, is how are you going to improve that? So and you can have that discussion with your supervisor or the module lead. But not only that, is that you can think about the sort of the area or aspects that you are interested in exploring. So, AI or sort of large language models, or just machine learning, is you have the opportunity to use that technology or build that technology as part of your solution. Or if you're interested in cybersecurity, you could be building some kind of defense mechanism or some kind of assessment or sort of threat monitoring system. You could be sort of accessing and sort of capturing the network traffic and looking for certain things, or you could be interested in cloud computing in terms of sort of resource management, or stuff. I mean, it's so big. The key thing is pick something. I mean, maybe it's so big that it becomes stressful, in which case have a conversation with your supervisor. But the key thing is that this is your opportunity to spend 2 or 3 months working on something that you are really interested in about. And like I said, at the end of it, you could sell it as a sort of a service, or look to market it as a service, or you could spin up a business from it, or you could use it to get into different areas of research. So it's a phenomenal opportunity to do something that you're interested in and get the qualification from it. Next slide, please. So the key thing is what do we really need to do? What are the steps that you guys need to think about? So the first thing is what area of interest do you have? What are your areas? And it doesn't have to be one thing. It could be many things. From the area of interest, you need to think about what sort of problem exists within that area of interest. And sometimes people think the word problem is a negative thing. A problem is a challenge that needs to be solved. Or it could be a frustration, or it could be an issue that doesn't allow people to do what they need to do quickly, or it creates friction for people to do something. So think about the area that you're interested in. From the area you're interested in, think about what problem exists within that area that A, you're interested in, and B, would align with perhaps your career goals or your professional goals or your academic goals. Once you've identified the problem, you can then do some research. And this is where you can use tools like sort of, ChatGPT or the other online tools. And you can use those tools to help you refine the sort of area that you're interested in and the sort of problems that might exist. And it's not that you're using AI tools to solve the problems. You're using AI tools as a tool for you to solve the problem. And that's a really good distinction. So you do some research, you find out about the problem, you find out, is there existing systems or is there existing solutions? What are the strengths of those solutions? What are the weaknesses of those solutions? And then you need to think about, well, what are you interested in doing? Are you interested in improving the existing system? Are you interested in implementing a system that doesn't yet exist for this problem? Maybe you then want to do some research to find out, does any system exist? Has somebody tried this and it doesn't work? And if it doesn't work, are you going to do something the same, or are you going to do something different? And then finally, really, how are you going to evaluate what you've done? How are you going to say what you did was good or bad or excellent or could be better? And the key thing is, if you say that this could be better, that doesn't necessarily mean that what you've done is bad. That means that you've identified weaknesses in what you've done, and you can explain what those weaknesses are, and you can explain sort of how they've come to be, and how you might resolve that or kind of avoid that in the future. And that's what we're interested in. We're interested in the story. What did you learn from this project? What did you learn from investment in this time? Next slide, please. So the thing, is what problem are you genuinely interested in? That's the key question. So, I'd say to you that the project should be your biggest challenge and your biggest enjoyment. It might be frustrating, but that's the thing that's going to give you your grade. Is pick something that you are genuinely interested in. If you're not sure currently what you're genuinely interested in, think about, well, what motivates you. What sort of job do you want to be doing in 2 years, in 5 years? And what skill sets or what experiences would you need to show to help open up those doorways for you? So the key part is, what are you going to be genuinely interested in? I mean, there's, the BSc is a 300-hour project and the MSc is a 600-hour project. That is a lot of time to be bored or do something that you're not interested in. So make sure that what you decide to do is something that you are genuinely interested in doing. Because if it's not, you will struggle to be able to invest the time. You won't want to invest the time, and inevitably that will then reflect in the sort of the outcome that you achieve from that time. Next question, please. Next question. Wait, next slide. So I thought I'd sort of take a little bit of a sort of a change of direction here and think about sort of some example projects that you might be interested in. Now, typically when you engage with them, when you come to the University of Herts and you complete modules and then you get the opportunity to do your project, is a lot of the time students are at that point, well, I don't know what I'm going to be doing. So the key thing is, I would say to you, think about something that you want to do now, and there's nothing stopping you from the moment that you enroll in the university. There's nothing stopping you from actually starting to think about that project and starting to do some research. The key thing is that the earlier you start thinking about that, the better. Because when it comes to the sort of that window of dedicated time, it just gives you less stress, and managing that stress and those pressures is a really important skill set. So one of the possible projects that you might want to do is some kind of AI study assistant. So, students struggle to identify knowledge gaps. So that's something that I'm aware of, being in education, is that is a common thing that students sort of clearly are not sure about. It's like, some kind of study assistant. So you can start thinking, well, actually, a study assistant, I could explore AI technologies with it. I could look at what sort of students want. I am a student, or I will be a student, so I have first-hand knowledge of that. So you could take your experiences and you can think, well, how could I have solved that problem? And can AI, and what type of AI could solve that problem? So the key thing is thinking about sort of, is this a personal problem? Is this something that I'm interested in solving? Am I interested in the technology behind it? Can I apply it? Can I does it have an actual value? Is it a real problem? And the answer is yes to all of those things, really. And then the key thing there is, well, maybe what sort of level should your project take it to? What would be a reasonable and genuinely achievable sort of outcome for the time that you have available for this AI study assistant or AI study buddy, whatever you want to think about it. But the key part is, this might be something that you get excited about, something that you might be interested in using yourself, but also it might be something that actually could be used, and as such, could it be deployed in the university? Could it be deployed as sort of an online platform? And then part of it really is you thinking about, well, how can I do this? What does it need to do? How do I know how people want to use it? So one of the key things is, once you've got your basic idea, I would say to you, don't think about starting a project with, I'm going to use AI. That's not really a great way to start a project. Start your project by thinking, what problem am I going to try to solve? What problem am I interested in solving? That's a much more interesting, much more sort of useful way to start the project. Next slide, please. So if we take this AI study buddy, maybe our life cycle would be that we're going to do some literature review. And a literature review is sort of an academic sort of term for, I'm going to go and find out about this, about sort of what currently exists, what challenges exist, what opportunities exist, how different technologies might be kind of utilized or engaged with that can solve this. Should it be a mobile phone app, or should it be a desktop app or a tablet app? Because those different technology platforms provide different opportunities and different challenges. So your literature review is really where you're going out and you're trying to find more about the problem domain, and then you're going to write the story of what you found, maybe write some of the questions that you're interested in finding out, and then document some of the answers, and you'll probably find that half of the people say A and then half of the people say B, and then you can have the final thing to say, well, actually, with the current scope or the current type of problem that I'm interested in solving, A is better, and not just A is better, but why is A better? So, and then you kind of figure out, so, well, this is what we're going to use. We're going to use a mobile technology stack because students, very rarely sort of sit at a desk. They're going to be walking around. They're going to be thinking about stuff on the move, and they're going to have a mobile phone. So we're going to stick with the mobile phone. And then, well, how are we going to get people to interact with it? So maybe that's part of your literature review. So a literature review is you are researching existing literature. You're basically looking at findings, technical papers and white papers and maybe industry standards. So you're reviewing information and data that already exists. Then you're going to do some sort of gap analysis, and a gap analysis is, well, where are the holes in this? Are the holes important or are they not important? Is my product or my project going to sit within something that doesn't currently exist? And if so, what is that, and why do you think that gap exists? So you can talk about sort of where your project will sit in the big picture stuff. Then your prototype. So your methodology for this is, I'm not going to try to solve the whole thing. I'm just going to build a very simple prototype that allows me to deploy a simple AI chatbot on a mobile phone. That's going to be my first prototype, because if I can get that, then that's going to be the basic mechanism for interacting with my system. And I'm going to get some user testing. So the user testing is your research. So you've used secondary research for literature. So you're reviewing other people's research, but your user testing is primary research. That's research that you're going to conduct yourself. It doesn't exist. And primary research requires ethics approval by the university, and effectively it means that you have to sort of demonstrate how you're going to collect the data, how you're going to use the data, when are you going to collect the data, how are you going to secure the data. So user testing is really valuable, but a lot of times students use user testing, but they don't use it well. It doesn't really add any value. So I would say to you is, think about how are you going to use sort of your own primary research, in this case maybe user testing, to really lift your project to the sort of the next level. And then finally, how are you going to evaluate it? So again, this is a sort of just a simple project life cycle for something like an AI chat study buddy type thing. Next slide, please. So in terms of that evaluation, we might want to think about accuracy or usability or learning outcomes or user satisfaction. So we can pick how are we going to measure the effectiveness of our solution. Accuracy might be how accurate is the information given back, or how accurate is the prediction of what's needed. Usability might be how easy is it for people to use. So usability, you could ask people to engage with your system, give them a questionnaire, ask them to complete things out, and then give you that survey and you do some analysis. Optionally, if you didn't want to go down the ethics route, where you have to apply for that, is that you could look at some kind of usability mechanism or methodology, and you could complete that yourself and then document results and then do some analysis on those things. It might be on learning outcomes. Your AI might be able to sort of provide help and support on certain elements, in which case, what are those elements? Or it might be on user side, how satisfied, how happy, how usable, how much of a problem does your solution solve? So again, in terms of how you're going to evaluate it is really, really important. But again, there's nothing stopping you from using an AI, assistant yourself to help you refine and build up your ideas. The key thing is that you can't use AI to create content for you, but you can use AI as part of your research methodology. Next slide, please. So another example might be some kind of cybersecurity detection system. So you're interested in cybersecurity. Maybe your degree is cybersecurity related or network related. So you're interested in sort of threat detection. So part of the key things really are about sort of, what does that mean? You've got threat detection, and then you got sort of threat avoidance, where you're trying to mitigate any threat. So part of it is really sort of, what are you trying to what are you trying to do? So the problem in this instance really is to be able to detect phishing, and malicious traffic on the internet. So then the question is then, well, how can I do that? And part of your research might be looking at how this is done from a technical level, how it's done from an operational level, so that you're building up your understanding. So again, some of the stuff we've already talked about can apply to this sort of project as well. Next slide, please. So the key thing with this one might be well, how do we identify what is malicious behavior? So again, part of your literature review might be to understand, what sort of malicious behavior there is and how that can be detected. And also, are you going to capture or are you going to deal with all of it for your project, or are you just going to deal with a small section of your project? Now, given the time frame, I would say to you, there's nothing wrong with you sort of reducing the focus and the scope of your project to make it more consistent, make it more focused. So it doesn't do everything, but it does this. And then the next thing would be to think about, well, how would you assess that? Next slide, please. So you could evaluate on things like precision, recall, false positives, and comparison with a baseline. So again, as you go into sort of AI and sort of comparisons, is precision has a certain degree, has a certain sort of terminology, and recall has a certain terminology, and false positives have a certain technology, certain terminology. Sorry. So the key thing there is how are you detecting and monitoring the precision of your threat detection? How are you identifying, what are the false positives? What are the true positives of your detection? And then how does that compare with some kind of baseline? And you might find that your project is horrible compared to a baseline. And that doesn't mean to say you're going to fail. That means to say that what you've done is ineffective with regard to the problem, or is less effective than current systems. So then you have the opportunity to go, well, why is mine less effective? What are other systems doing? And that's a really good opportunity to demonstrate learning and understanding. So even though your project doesn't do what you wanted to do, or doesn't do it at the level that you want to do it, it doesn't mean to say that you're going to get a bad mark or even fail the project. As long as you can explain, and tell the story of what this means and how, when did you detect this? Why do you think this is the case? And how could you improve it? Or if you did this again, what might you improve? So again, it's don't panic if you don't know whether you can do it, because that is the perfect start of a project. That I don't know how to do this, because the methodology of the project is to work out, well, what do I need to do? When do I need to do it? How do I know what I need to do? So the key things is the project is it's scary perhaps, but it's a really good opportunity to do something and learn something. And unlike industry, if it doesn't work, that doesn't mean to say that you're going to fail. The only reason why your students would fail is because either they didn't do the work, or they didn't engage with the process. That's it, really. I mean, they didn't do the work or they didn't engage with the process. As long as you can demonstrate, the learning, and you can demonstrate what you did and why you did it. So as long as you investigate, and sort of engage, you will pass. That's the key. That's the key element. If it doesn't work, don't lie. If it doesn't work, try to understand, well, why doesn't it work? That's the difference between sort of an academic project and an industry project. Next slide, please. I'm aware that we're running a little bit low on time, so I'm going to kind of push it a little bit more. So another example is some sort of smart campus app. So something that students would find useful as they engage with the university campus. So maybe improve access to services, or room location, or study groups, or anything basically. So the key thing here is this something that you're interested in doing? Is it something that you can relate to? Likely. Is this something that interests you in moving forward in terms of sort of app development, or sort of human computer interaction, or sort of usability elements, in which case something like this might be a really great project. Next slide, please. So thinking with this, you might think about, well, stakeholder analysis. So stakeholders are people that are interested, or organizations that would be interested in this. So who are they? You've got things like students, you've got tutors, you've got the state teams, you've got service providers, maybe sort of social groups. So they are all stakeholders. They would all be interested in this sort of element. So what are their requirements? What are the user stories? How does a user from a different stakeholder, or from multiple stakeholders, what do they want? What are the things like the functional requirements? What do we need the system to be able to do. So again, all of these elements can relate to all of these projects. Next slide, please. So with regard to this sort of thing, maybe with user experience and usability, so we can, how long does it take to complete a task? What is the efficiency of that? How do people feel? Is it frustrating? What's the frustrating part? If there's accessibility issues, how do we support those? So again, these are different aspects that you can evaluate your project on. I've got a couple more. So let's go to this next slide, please. So again, another example, maybe some cloud deployments. Next slide, please. So with the cloud deployment, we could be talking about Docker, containerization. We could be talking about deployment methodologies like CI/CD. We could be looking at, well, how do we monitor? How do we know that people are using the system? And then how can we scale up that system? So these are all aspects of software engineering, but they're also aspects of cloud deployment, because cloud deployment is effectively sort of, we've got services on demand. And all of these elements link to that. So if you're interested in software engineering, you're interested in sort of cloud engineering, these are all different sort of aspects that you might find useful to build up some skill, or just, explore, depending on what you're interested in. Next slide, please. So let's sort of change the tone a little bit and talk a little bit about project life cycles. I've given you an example of a basic project lifestyle, but let's sort of next slide, and we'll go through this in a little bit more detail. So effectively, any project from an academic, whether it's an MSc or a BSc, really is about the literature review. What questions would be useful for you to know? Technical questions, academic questions, scholarly questions, what are they? And what would be useful for you to know? Then from there, you can think about, what are the requirements? What does my solution need to be able to do? And then the design is, what is it going to look like? What is it going to feel like? How is it going to work? The implementation is really about, okay, we understand what we need to do, but now the question is, how can we build that? How can we sort of make that implement? How can we bring it into reality? Testing, evaluation, and reflection. We've already kind of talked about those a little bit, so I think we'll skip those. Next slide, please. So the BSc and the MSc, what's the difference? So essentially, the BSc, it is sufficient for you to decide to build something. So you might want to build a chatbot, or you might want to build a web portal for something. The MSc is, the first thing you have to do is you have to identify a research issue. So you have to identify some existing system within sort of the area that you're interested in. So effectively, the difference between a BSc and an MSc is the MSc requires a much deeper investigation. It requires sort of higher levels of sort of critical evaluation than the BSc. The BSc is sufficient for you to decide to build something. It could be a game, it could be a business app, it could be a website, it could be an e-commerce platform, it could be a chat bot, but it's sufficient for you to build something. The challenges is to identify the challenges, to identify the methodology, and then to build it, and then to test it. With the MSc, you have to first start with a research question. So those are the two sort of distinctions. But other than that, the much of the mechanism is the same. Next slide, please. So what makes a high quality project? Just not even a BSc, but a project, is a clear research question, or clear research questions, evidence-based decisions. What decision did you have to make? What options were there? Why did you pick this? And then reflectingly, how well did that go? Did you look at other elements? If you did this again, could you have done a better job? So the rigorous evaluation and the critical reflection are sort of retrospective, whereas the clear research and evidence-based decisions are aspects that you did, and why did you do them? So again, it's that critical thinking, is being able to not just to make a statement, this is good, but to explain why this is good. Next slide, please. In terms of common pitfalls, so the four things that students commonly fail is because they overscope their project. They define their project as being too big. They think it has to do everything and is available to everybody. Don't do that. Is pick a problem that has sort of edges. Pick a problem that has a sort of a clear scope to it. A poor or a weak literature review is another issue. Is that they they basically don't talk about what they wanted to find out. They just review 3 papers or 4 papers. That's never going to be a good start. Or they have a poor evaluation. They say, well, this is the best it could be. That really doesn't help at all. Why is it the best it could be? What things could be better? So again, it's really a question of they're not really engaging in a critical way of thinking, or they leave the writing till it's too late. So for example, you might have a 12-week window, and then I would say to you, depending on how depending on how much experience you have and how fast you write, is I would say to leave at least 2 or 3 weeks at the end of the project that you are just purely focused on your report, because it's not the practical stuff that will get you all the marks. It's the actual ability to talk about your decisions, about the challenges that you had. That's where you're going to get your mark. The practical stuff really is just the vehicle for you to tell the story of your project. So don't leave the writing until too late. In fact, I would say to you, start your reports as soon as you start, because you can use that as a living document. You can keep notes in it, and then it just means in that last sort of week or 2 weeks, you don't have to try to think about what you've done. You can just sort of edit what you've done, and that will give you a much better opportunity to get the marks that you deserve. Next slide, please. So we talked a little bit about scope. Is sort of, it's kind of like Goldilocks zone. It's not too large, not too small. You don't build the next Facebook. Find a problem that you're interested in. Reduce the scope so that it's still a challenge. So you don't know that you can do it, because if it's too easy, you're not going to be challenged enough. And if it's too hard, it's going to demonstrate that you can't manage that. And that's one of the reasons why working with your supervisor is an excellent resource. It's better to evaluate a recommendation feature. So the key thing for you is don't make it too large. Think about the scope of your project, discuss it with your supervisor, think about how you can evaluate it, and you can do all this without any single line of code. And you get the scope right, and it will make your job easier, and it will give you less stress. If you find that the scope is too big halfway through the project, adjust your scope. Just make it simpler, and explain in your report and in your Viva, the demonstration that you give, that you realized the project was too big and you tiled it back. And that's not a bad thing. It's a really good thing. Next slide, please. So I would say to you, when you join the UH and you start your project module, is that you'll be given, help and advice on all these things. But I would say to you, as a general good rule of thumb, the first week of your project is to explore the ideas and the areas that you're interested in. The second week is to do that first, that initial literature review. Now, from your initial literature review, you will have other things that you'll find out, and you'll want to do more research. But that first week is just to kind of scope out that area. And then week 3, you refine what it is your project is going to do. And then in week 4, you define your objectives. I think that's a really good start to a project. Again, it's not for you to do that. That would be my suggestion, to adapt that around, the way that you work, because that's really what you'll understand more. But I think if by the end of the 4th week, you've got a good project, you've done at least a good initial review of the literature, you've got a good scope, and you've got your objectives. That means then the rest of the 6 weeks, you can actually focus on designing and prototyping, and coming up with how you're going to address those objectives. I think it's a really good way to start a project. Next slide, please. So you'll be given a supervisor, and a lot of times students think that their supervisor is there to tell them what to do, or their supervisor is there to give them permission, or their supervisor is there to give them a project, or they have to wait for their supervisor to start. Your supervisor really is a critical friend. Your supervisor is not there to give you approval. They might give you approval, or they might not give you approval, but that doesn't mean to say that you have to accept it or decline it. They'll give you some guidance. I think of them like a lawyer. Is that they're gonna listen to what you want, they're gonna listen to the problem, and they'll provide you with some guidance. And it's up to you to work with them and have that conversation to say, well, I agree with that, I don't agree with that. Ask them. If you're not sure about why they've suggested something, ask them. They're there to challenge you. They're there to help prepare you for that interview process at the end. They're there to give you some feedback, and they're there to give you some academic support. So they are a really valuable resource for you to use, but they are not there to make decisions for you. They can help you make decisions, and they might offer some suggestions, but you are free to, this is your project, it's not their project. And as such, you, the student, this is it's entirely your responsibility to build and to think about, and use them as a critical friend. Use them to help prepare you to make sure that it makes sense and that you can answer questions in a Viva. Next slide, please. So how do we get success? You have to do good research. You have to have good technical quality. You have to have good evaluation, and you have to have good communication skills. If you're not sure about research, the university has some phenomenal research support teams that will help you do that, plus your supervisor. In terms of technical quality, again, your supervisor, you can reach out to other members of staff that you have a good experience with regard to other modules. So programming, you can reach out to those guys, or you can reach out to the module leader, or you can use YouTube videos, or you can use AI to help you build up those technical skills. In terms of evaluation quality, that's really where you are reflecting how well did things go. And if you can be honest and open and truthful, then that even if that shows that it doesn't work, that shows professional standards. And part of the communication quality is making sure that you are able to describe what you're doing, you're able to explain why you did it that way, what you were trying to achieve, and what the outcome was. And if you have a problem, you're trying to sort of communicate, this is the problem, this is what I did, this is what I'm struggling with, and I can't seem to find a solution. Can we have a conversation? So these are really useful things to think about: research quality, the technical quality, evaluation quality, and the communication quality. If you can demonstrate high sort of value at those aspects, you will do well. And even if you don't have the technical quality or the technical skills at the beginning of the project, you can identify those as things those are risks to the project. So then the next question is, well, how are you going to try to mitigate those risks? So you might use technology, you might use AI, you might use a low code or no code environment to create prototypes. Or part of the problem might be that you want to build your technical skills. So how are you going to build your technical skills? What challenges does that present? So again, this is your project, and how you sort of direct the project and control the project is entirely up to you. Next slide, please. So the key thing is, as I mentioned at the very beginning, is this is an excellent opportunity for you to establish a portfolio. It's an excellent opportunity for you to practice your sort of interview discussion skills and also demonstrate professional credibility. And if you can kind of create this as a sort of portfolio piece, like have it published on GitHub or something like those, then when you go for that job promotion or you go for that job interview and they say, well, show us what you can do, or can you tell us some challenges, is that you can pull this up and you can walk through the challenges. And hopefully, if you pick the right project, this is something that aligns with those next steps that you're interested in doing. And again, your supervisor and the module team and just the wider teams at the UH, have excellent capabilities, and I'm more than happy to help, providing you explain the situation, because we can't mind read. So that's the one thing I'd say to you about that, is just reach out, engage with your supervisor, engage with the module team, demonstrate what you're interested in doing, and also why this project is really useful for you, because that will help you make sure that you have the drive and passion to invest the time needed. Next slide, please. So the thing is think about the problem, think about the users, think about the technology, and think about how you're going to evaluate that type of project. Next slide, please. So as a key takeaway, try to think about what is ambitious to you. How are you going to evidence what you're interested in doing? What sort of technical skills, do you need or do you have? And then what are your critical reflections? So those are the key elements when you're thinking about the project. Last slide, please. Thank you very much. I appreciate I've been talking for the best part of an hour, and I'm more than happy to try to answer any questions that you guys might have. Thank you very much.
Thank you so much, Mike. That was an absolutely brilliant session. It was so informative and so useful for our applicants to hear as well. So thank you for that.
Yeah.
If anybody has any questions for Mike at all, then please do post them in the Q&A section, and then we can ask Mike those live. We'll just give a few moments for questions, because I understand we're at the hour now. But Mike, I've got a question for you. Do you have any top tips for international students coming to join these, the School of Physics, Engineering and Computer Science in September 2026?
I think it's an excellent question. And one of the things that I see just from my personal experience with international students is, first of all, they want to achieve success, which is great. I think the key thing is for them to understand that achieving academic success really is about the investment in terms of the modules. So pick a course, whichever sort of program they're interested in, make sure that that aligns with their area of interest. That's the first thing. But a lot of the modules are sort of coursework driven. So there is flexibility and freedom for them to invest time to build up the evidence. When it comes to the project, a lot of the times, the students feel that there's not a lot of pressure on them. So, for example, they might have at the start of the semester, they might be sort of 10 weeks or 12 weeks before they have a sort of a real deliverable. And they think, well, I can do some of the stuff, or I can do some. The problem is that way lies to high levels of stress, because it's the key thing is it's a marathon. It's a bit like you want to get fit and strong. You've got 12 weeks to get really fit and strong. You can't leave it to week 10 and 11 to start going to the gym. You're just going to be tired. So the key thing is to pick a project they're interested in. Don't make it too complicated, don't make it too simple, and then start doing some research. But more importantly, I think, again, is students panic because they don't want to fail. And because they don't want to fail, they end up doing things that are sort of considered academic misconduct offences. But the key thing is that they panic because they think it's got to look good, that it's got to work, and that's not the case. If we were in industry, that would be the case. It has to work and it has to look good. But we're academics, so what we're interested in is what did they learn during the course of the 12 weeks. So it's about taking their time and making sure that each week they're investing, time that they need to invest to do what they want. So it's a marathon where they have to invest sort of, regularly each week throughout the course and engage with their supervisor. So their supervisor is a bit like their lawyer, and they can advise them and they can sort of help them understand what needs to be done. And that way the students will pass. That is the way students will pass. If a student has 10 years of software engineering experience, maybe they can leave it to the last sort of 4 or 5 weeks. But a lot of our students are moving from different technologies, or they don't have the experience. And this task is not about doing it exceptionally well or producing a really high polished artifact. It's about the journey that they took, and really what is the evidence of the journey they've taken. That would be my suggestion. Is don't panic about it looking shiny, but actually panic about sort of how are you managing your time regularly through the course of the module. And if they do that, they will pass.
Fantastic advice. Thank you so much, Mike. We've had a few questions come in. So if you have time, Mike, for me to go through those few questions with you as well.
Sure.
Is that okay? Thank you. So a question here, someone said, what advice would you give a student transitioning into the MSc Computer Science programme?
Transitioning from, do we know where they're transitioning from?
Yeah, I'm not quite sure where they're transitioning from. So that is a really good question.
I would say if they're coming from a non-computer science background, is there's going to be a less expectation for them to write lots of code. So the key thing for I would suggest them is that they use a sort of a prototyping methodology. So instead of trying to solve the problem, is to try to break the problem down into small chunks, and then just try to solve each of those small chunks. Because even at the end of the day, if they can't put all those things together, they can still showcase those experiences. And again, this is not an industry task. This is an academic task. So what we want is evidence of engagement and learning and challenge. And how do they, and even if what they did doesn't work, that's not a deal breaker, as long as they can explain, why they tried it that way. And if they had more time, how could they improve it?
Fantastic. Thank you, Mike. That was a brilliant answer. So I've got another question here. So a student said, well, hopefully a new student joining us said, for students who come with existing production projects like business systems they've built professionally, can those become the foundation for the MSc project, or does the project need to be something completely new?
So there's a bit of a rule within university is that if something already exists, you can't then reuse it. This has to be a sort of a new challenge. But saying that, there's nothing stopping them from re-engineering it or sort of pivoting it in a slightly different way. The key thing for an MSc is the first question they have to think is, what is the research question? If it was a BSc, then they can just build something. But as an MSc student, they have to first start in the sense that there is a problem with something, and that's the first thing. If they can think about that and they can use that first production piece as a trial, and then they can look at improvements, is that I can't see anything wrong with that. But again, they can talk to the supervisor about subtleties and sort of slight edge cases.
Perfect. Thank you, Mike. And so a final question for you. Someone said, how should we best manage our time for the projects when we're undertaking any of the MSc computer science courses?
So that is a huge question. And the key thing is that the project management really is about managing resources, and time is one of your very, very limited resources. So the key thing I would say to you is, first of all, think about, how do you deal with time yourself? Are I'm always a bit of a last minute person, and I've built up skills to allow me to kind of live a little bit like that. But the key thing is, if I'm aware of that, that's a risk. So now the next thing is how would I avoid that? And part of it really is looking at what the outcomes they need to deliver, and maybe working backwards to think about, well, I need to deliver this by this date. How long do I think it will take me to do it? And then I always advise my students, there's a sort of a law called Hofstede's law, which basically says that it's always going to take more time than you expect it to take. So as a rule of thumb, I tend to times it by 2. And even that is probably understating it. So maybe a times by 2.5 or a times by 3. And then they basically, they can time box backwards, and they can go, well, I'm going to run out of time, in which case they may want to kind of simplify what they've done, and again, then give themselves some milestones. So I would say to you, look at different project management and time management methodologies. And as part of your project, talk about how you're going to manage that time and why it's a risk and a challenge for you as an individual, and how you're going to try to mitigate that. And even if you can't mitigate it, the fact that you've tried to mitigate it and there's evidence there, then that will give you marks. That will help, give you marks. So again, it's like it's everybody manages time differently. And I would say, look backwards, try to give yourself enough time, and then double it, and then see where that fits, and then see if you can kind of squeeze some of those boxes around a bit. But time management is an excellent skill to build.
Definitely. Great advice. Thank you so much, Mike. And that will really support them throughout their course and, throughout their professional journey as well, time management. So yeah, that's fantastic advice. Thank you so much, Mike, for the session today.
It's been my pleasure.
Thank you. Well, just in case, everybody, if we haven't had time to answer your questions, don't worry. You can see on the screen all the different ways that you can contact us. On our website, we've actually got a chat bot on the international pages. We've also got our email address, our phone number, and then you can contact us via Instagram, Facebook, and X as well. But thank you so much, everybody, for joining us for today's session. And thank you, Mike, as well. But we hope to see all of you in September.
Thanks, Jess. Good luck, everybody.